Howdy, howdy, howdy. Are we ready to get going today? Gonna do some exponential functions tonight. It's not too bad a lecture. Good evening. How are you? Hey, September. How's it going? Did you finish after we worked for a little bit? You went off and did dinner and haven't seen you since? Or are we going to work more on inverses tonight after class? What's the plan? What's the plan? What's the plan, man? Worked today a little bit. Austin worked on his homework. Robin worked on his. Saw lots of people online. So was working with a person or two. Good job, guys. I was fighting with Randy over having more students than him. That's the plan. I have to have more than him. Did y'all get a lot of rain? Did you see a storm at your place too, or was it just here? All right, we'll finish tonight. Amanda, did it rain at your place or no? Did it just act like it? Threaten? It rained here, like it rained. It rained. It did rain, yeah. Yeah. Rained. Man, took down the fence. Craziness. It was a raining. Hey, Jacob. Woo! Yay, way to be September. Way to go. Way to get him here. Way to be here, Jacob. Yay! Look at that. Step 1, made it to class. Hey, Thomas. Now, step 2 is after class, you join us in Discord and we all sit around and do homework together. That's the plan. I'm pretty impressed, September. I don't know how you did that. It's pretty impressive. Got in here. That's really, really impressive. Hey, Austin's here. Hey, Fernando. We missed you on Monday. He's here now, though. Got you here. That's what we need. Get everybody here in class. Here's our early bird today. See if y'all can do this. I bet y'all can give me the answers to this. Just to simplify the following. What's 2 squared? What's 2 to the first power? What's 2 to the 0 power? What's 2 to the negative 1? And what's 2 to the negative 2? See if you can answer those. Do that early bird real quick. Driving home. Oh, get home safely first. Just listen to us in the background. You don't have to watch. Hey, Marissa. How's it going? Glad you're here. Way to make it to class. Good job. We got this. And if y'all did last time's homework, if you did the inverse homework, then this one should be a little easier, maybe. Maybe. Hey, Cheyenne. Y'all fight out the rain, make it through. Just like me, stay in the house and ignore it completely. Hope the internet doesn't go down. That's good. As long as my power doesn't go out, I'm fine. Gotta have the internet though. Gotta have the internets. Internets are important. All right, well, let's get started. Y'all didn't answer my questions, though. Y'all didn't give me my early bird. Give me the answers to my early bird. What's the answers to my early bird? What is 2 squared? What is 2 to the first power? What is 2 to the 0 power? What is 2 to the negative 1 power? What is 2 to the negative 2 power? Y'all answer those. What are those? Grassy fields of dreams, Gentle winds from far away, resting in the shade. Grassy fields of dreams. Yep. Gentle winds from far away, resting in the shade. Yes, I don't know about that. Yeah, I like the 4, Jacob. 2 squared is 2 times 2 is 4. Good. What's 2 to the first power? 2, yes. What is 2 to the 0 power? I like the 4. 4 was good. Oh yeah, 2 to the 0 power is 1. What's 2 to the negative 1? Because remember, any non-zero number raised to the 0 power is equal to 1. What's 2 to the negative 1 power? You remember what that is? 2 to the negative 1 power? Remember the 2 to the 0? Like if I have x to the 5th over x to the 5th, that just becomes 1. But if we do the little rules, you've got 5 minus 5, which is 0. So x to the 0 is just equal to 1. Remember doing that? Anytime we used those rules when we were dividing, we would just subtract. And that gave us x to the 0. But that's also when you have the same thing on top and on bottom, it just equals 1. So that's also just equal to 1. So anything raised to the 0 power is just equal to 1. And then, you're right, Cheyenne, 2 to the negative 1 is 1/2. Because again, remember if you do x to the 5th and x to the 6th, where this one on bottom is bigger, so that you've got 5 minus 6, you get that negative 1 down there. But think about what's happening. 1, 2, 3, 4, 5, and on bottom 1, 2, 3, 4, 5, 6. Well, these guys become 1, and you're left with an extra 1 on bottom. So that's always equal to 1 over the number. So here you got 2 to the negative 1, that's equal to 1 over that number. So that negative number always reciprocates it. That reciprocates it. So this is 1 over 2 squared, which is just 1 over 4. So 4, 2, 1, 1/2, and 1/4. We need to remember this because we're going to be dealing with these exponents tonight and then all next week. Yeah, what does that negative exponent do to it? You remember? You remember it clipping it? You remember all that? That's been a while. It was a long time ago. Ages ago, we did that. Ages ago. So today we're going to graph exponential functions, and this is going to be important. And then next week, well, at the end of class, I'm going to show you the inverse of these exponential functions. And next week, we're going to cover logarithms. That's all next week's going to be logarithms. Lots of logarithms. So let me just tell you what an inverse function is first. An inverse function is just some function where we have a base raised to some power. Now notice that my x here is in that exponential place. So my input goes into my exponential position. And that's what that is going to make that exponential. I'll give you a little more detail though. This b, where the base, we'll call it b, is a positive constant. So in other words, this b is some positive number. So in my exponential functions, my b has to be a positive number, like 2, 3, 20, a half, 16 ninths. But it's not going to be a negative number, not like -2. It's a positive constant other than 1. So this b down here is some positive number that is not 1, because when we raise 1 to any power, it's really boring. It's just 1. 1, 1, 1, 1, 1, 1, 1, 1. So any number other than 1, and x, our input here, is any real number. In other words, for my domain, my x can be any real number. So for all of the domains of our exponential function, the domain of all these exponential functions is going to be all real numbers. So as I ask you later, what's the domain of our exponential functions? Well, the domain is just x such that x is a real number, or from -infinity to +infinity. That's going to be the domain of all of our exponential functions. That's what this says. X can be any old real number. I can input anything. All right, we're going to graph these exponential functions tonight. But let me show you a couple other things before we get started on graphing it. So I said where b is a positive constant. So this number, I can have this as a function. Notice that 2 is a positive constant. It's just some positive number. I cannot have that. There, my base is a negative number. That's not an exponential function. So no, but yes. Okay, but I'm really going to confuse you. This is okay, because in this case my base is just 2. It's 2 raised to that power, and then it's being multiplied by this -1 out front. But my base is just 2. Not -2. So in this case, my base is -2. This is not okay. Here, my base is a +2. That is okay. And this has to do with that order of operations. It's because we have to raise this to that power and then multiply it by that negative. So if I have this, -2 raised, let's do it to the 3rd power. What that says is I'm doing negative times 2 times 2 times 2. I have to raise it to this power first and then multiply it. Then find the opposite of it. So I end up with a -8. That's different than if I put the negative there. Two different things. Or maybe I should do 4 just so that will be different. If I do a 4, that's 16 in there, so I end up with a -16. Whereas if I do it this way, I would end up with a +16. So that's sometimes why people use calculators and yet miss it. Because if they put it in as a -4 to -2 to the 4th power, the calculator is going to tell them -16. If they meant -2 to the 4th power, then the answer would have been a +16. So you have to be careful with that, with the exponents. That exponent comes before that sign. Okay, so with that knowledge, we are now going to graph this function. We're going to graph that function. And the function we are graphing is f of x equals 2 to the x. Now, exponential functions are a little bit different from our other functions. You remember with our other functions, we had a parent function for all the rationals. We had a parent function for all the linears. We had one parent function for all the quadratics. But with exponentials, they have a parent for each one of their family members. So in other words, for this function, anytime I have 2 as its base, this is the parent for that particular function of that with that base. But he's going to be different. That parent is going to be different than this one. Because in this case, the base is 1/2. This one is the parent of all his functions that look like him. So I'll show you a little more about that. But with exponential functions, each of their bases being different means they have a different parent to go along with them. So in this case, he is the parent. This is the simplest exponential function with 2 as the base. We'll graph that first, and then we'll do a transformation, or another family member, we'll do a transformation of that. We'll do this. We'll do 2 to the x plus 5. I'll show you that one. Okay, let's just start with a nice parent. With the parent, since I can use any real number, I'm just going to use -2, -1, 0, 1, and 2. I'm going to input those since I can use any real number. So if I put in -2, well, we saw earlier, what is 2 to the -2 power? We did that in the early bird. What was 2 to the -2 power? Y'all know what that is. What is it? Let's see who's actually here and who's walked away. Who's turned on Netflix and is really watching that? Let's see. So remember that 2 to the -2. Oh, you're close, September, but flip it. Remember, do the reciprocal. So we're going to reciprocate it to make it 1/4. So that negative does reciprocate it. And then 2 to the -1 reciprocates it to make it 1/2. And then 2 to the 0 power, what's 2 to the 0 power going to be? That's just 1. And 2 to the first power is 2. And 2 squared is 4. Notice none of those are negative, September. None of those are negative. Not a single one of them. The negative numbers, those negative exponents, reciprocate it. That's what it does, is it reciprocates it. Okay, so let's graph those guys and see what's happening. -2, 1/4. So I'm going to go to -2, 1/4. -1, 1/2. -1, 1/2. 0, 1. 1, 2. 2, 4. Good, good. Now, as I get smaller and smaller out here, as I keep putting in smaller and smaller values for x, let's say I put in a -10. So I have 2 to the -10th power. Remember, that negative just flips it like this. So I've got 1 over 2 to the 10th. But 1 over 2 to the 10th, you know, this is some big number. 1 over a big number is really a little bitty number. So as I get further and further out here, I'm going to get littler and littler. I'm going to get smaller and smaller. I just mean that, notice this 2 and 1/2, that's the reciprocal. And Robin, I showed it earlier. If we have this, 5x to the 5th over x to the 6th, this is 1, 2, 3, 4, 5 over 1. That's a bad. Let me do it right beside it. X to the 5th over x to the 6th. That's 1, 2, 3, 4, 5. And on bottom I have 1, 2, 3, 4, 5, 6. These guys all become 1. Notice there's 1 down on the bottom. 1 down on the bottom. Whereas this is 5 minus 6 gives me, remember we could divide, when we divide, we subtract our exponents. So 5 minus 6 gives me that -1. So x, 1 over x is the same as that negative. So that's what I mean by reciprocating from here to there. When I have that negative exponent, it just flips it down to the bottom. It reciprocates it. It is kind of like the inverse in multiplication. 2 and 1/2 are inverses of one another. They make it into 1. Does that do that? 2 times 1 is 2. No, maybe not. I don't know. We think of it as multiplication and division are inverses of one another. It's a reciprocal. So that's what I mean, reciprocals. And it does kind of look like that. It does look like that, September, like last time, you're right, when we notated like this. But that notation doesn't mean the same as that exponent. We did kind of use that notation. Okay, so when I put in like a -10, I'm getting littler and littler. Well, if I put in a -100, again, I'm getting 1 over 2 to the 100. This is a big number. But when I get 1 over a big number, I'm really getting a little number. So the further out I go, the smaller and smaller numbers I get. But I never make it down to 0. I don't care how big a number I put in there on bottom, I'm not going to get down to 0. So we have something called that, another one of those asymptotes right here where y equals 0. There's an asymptote there where y equals 0. Cheyenne, if you're talking about the inverse function one, you can hop on. We'll hop on Discord later, and I'll work with you on on that. But I'm just teaching the exponential functions tonight. And if you're talking about exponential functions, give me through the lecture, and we'll see if I make it through there. I bet I hit on it when I'm teaching. Okay, now I'm going to connect these dots. So out here, it's getting smaller and smaller and smaller without ever making it to 0. This direction, I'm going to connect those dots. And if I put in 3, I'm going to get out a bigger number. 4, it grows really quickly. And we actually call this, I'm sure I'll get there then, Cheyenne. We call this exponential growth. You can see it is growing exponentially. So let's look at it and see. Notice that this domain is going further and further out. So if I look from -infinity here, you know, the arrow tells me it keeps going out, Rachel. And then it keeps going, the arrow here tells me it keeps going that direction forever and ever. So my x values are, it goes forever and ever. Now what is it that's limited? There's no picture down here. So that means that my range is limited. There's no y values down here. My x's are covered. I can put in negative 100 for x. If I put in negative 100 for x, I get this little bitty number out. If I put in a really big number for x, I'm going to get out an output. So I can put in any input and I'm going to get out an output. It's just my outputs or my y values are limited. They're only going to be from anything larger than 0. So while my domain is all real numbers, my range is limited. So here my range goes from 0, not included, it doesn't touch 0, to infinity. Or, as I'm talking about my y values, anything bigger than 0 is my range. Good. Notice that 0, 1 is my y-intercept. As I do these parents, we're going to see that over and over again. Because anything raised to the 0 power, when I input 0 into my exponent, I'm going to get out a 1. So in all these parent ones, I'm going to get out a 0 and a 1 as my y-intercept. So a few things on the parent exponential functions. The domain is always going to be all real numbers. The range on all these parent ones is going to be where y is greater than 0. There's on all the parents, there's an asymptote where y equals 0. And for all my parents, the y-intercept is going to be at 0, 1. So these are all true for the parent exponential functions. That's always true of my parent exponential functions. Now, we say this is exponential growth. We see that like out in the real world all the time. Right now we're seeing it with this virus. It is exponentially growing. As it spreads amongst people, it's growing exponentially. So it is growing exponentially. And this is exponential growth there. All right, I just grabbed 2 to the x for you. Now I'm going to take, here is a family member. Now in order to graph this family member, I first start with its parent, which I already did. And now I'm going to do something with this. You tell me, what do you think's going to happen? Think back to our transformations. What do you think's going to happen with that plus 5? What's your instinct tell you is going to happen? You tell me, what are we going to do? What's going to happen? What's that plus 5 going to do for us? To what, September? And why? Thanks, Amanda, for clarifying. What's going to happen to it? One of those nights. Good, Austin. Yeah, it's going to move up 5 on the y-axis. You're exactly right. Because it's not up there in a grouping symbol up there with the x. It's not up there. It's down, affecting my y values. So I'm going to take all my y values and add 5 to them. So in this case, this is going to affect my y values. I'm just going to take all my y values and add 5. Or I could have just taken my parent and shifted it up 5. So this just moves it vertically up 5 spots. So 9, 7, 6, 5 1/2, and 5 1/4. So this new function, this family member, has points at -2, 5 1/4, -1, 5 1/2, 0, 6, 1, 7, and 2, 9. Now, what about that asymptote? Where is the asymptote? What happened to that asymptote? Where is it now? Hey, Jacob, where's the asymptote now? Where is that asymptote? Yeah, magic. It just shifted it up 5 spots. We just added 5 to all our y's, and it also just shifted it up. Or we could have just taken the parent and shifted it up. So here it is being shifted up, but talk to me about that asymptote. Yeah, it's going to be at that +5. So all of your exponential functions need to have an asymptote. As you're graphing, I should see an asymptote on there. So when you graph these exponential functions, this should be getting closer and closer to that asymptote every time. Perfect. Yeah, it's actually at this y = 0, and I say it this way because it's that whole line. It's everywhere y = 0. Or not, you're right, not 0, 5, 5, 5, 5. You're right, at 5. So it's everywhere where y = 5. So it's a whole line, not a point. So, you know, if I did 0, 5, it would just be at this one point. But it's this whole line where y = 5. Everywhere where y = 5 there. That's where my asymptote is. And also notice my y-intercept moved up. It's now at 0, 6. So on my family member, the transformations that we did before are the same. It's just that here, my parent is going to be this without that. It's just the base and the exponent. That's all. All right, let's do another. Okay, now we're going to graph this thing. Yeah, you're right. We really should use, I'm being lazy. So really, you know, 21/4 and 10/11 is really where we really should do it. You're right. Most of the time, yeah, I was just being lazy. So most of the time we just deal with improper fractions to make it easier for us to deal with the math later. But it was just easier for me this time just to add those two together. I was just being lazy. Plus it was easier to graph. You're exactly right. It was easier for me to go 5 1/4. So if you do some of that where you put 5 1/4 and my answer says 21/4, I'm going to be okay with it. Okay, but back over here, I want to graph this function, but before I graph that function, I'm first going to look at its parent. So the parent of this one is just this one. Notice that he's a parent function and he's a parent function. So with the exponentials, each one of them has their own little parent. It's not like the linear and the quadratic where there's just one parent for them all. In this case, there's a parent for each one of them. All right, so I'm going to start by graphing him. And I know already some things. I know that I can put any number in. So let's start by doing -2, -1, 0, 1, and 2. If I put in -2 here, what is 1/2 raised to the -2 power? What is 1/2 raised to the -2 power? Remember what that negative does. It reciprocates it. You know, you could think of it this way. You could think of it as 1 over 1/2 squared. But this 1 divided by 1/2, keep, change, flip it. It just takes it and flips it around. So it just reciprocates it. It flips it. And then what is 1/2 times 1/2? Oh yeah, it's 4. It's 4. It's 4. Careful with that. 1/2 plus 1/2 gives me 1. But 1/2 times 1/2 is 1/4, because 1 times 1 is 1 and 2 times 2 is 4. So putting in that negative exponent just reciprocates it. Then, yeah, 1/2 to the -1 is just going to reciprocate it and make it a 2. Anything to the 0 power is just equal to, or any non-zero number raised to the 0 power is just equal to 1. Oh, let's look at it, September. What is 1/2 times 1/2? One times 1 is 1, and 2 times 2 is 4. So here, let me back up and let me do it a little better. So this says 1/2 times 1/2. So it's 1 over 1/2 times 1/2. But that's equal to 1 over 1/4. Because it's 1 times 1 is 1, and 2 times 2 is 4. If I were adding them, then it would be 1. Then you keep the first one, change that to multiplication, and flip him so that you end up with 4. So that's how we're ending up with 4. Yeah. At division. Got it. Perfect. Okay, then 0 power is 1. Raising it to the first power is just 1/2. And raising it to the second power, well, that's that 1/2 times 1/2, which is 1/4. She's got it. Okay, now I can graph it. Now let's do it. And Jacob right now is going to say hi to let me know that he's here. Because he checked in, but prove to me you're still here, Jacob. Say hi. Okay, I'm going to go -2, 4. -1, 2. 0, 1. 1, 1/2. And 2, 1/4. Notice that as I get bigger and bigger, like out here to 100, It's 1 over 2 to the 100th. Well, that's going to be multiplying 1 over, 1 to the 100th is just 1. But 2 to the 100th, you get this big number. Hey, there he is. There he is. Good. Okay, so there we get bigger and bigger. So we get, it's really that fraction's getting littler. So as the denominator gets bigger, it gets smaller and smaller. So we get really close to this y equals 0, but we never quite touch it. So again, same things are true with this parent, where we have a y-intercept at 0, 1. We're getting closer and closer to that asymptote without touching it. But this one, notice, is different than that one. On this side, we're exponentially growing. So like the virus is doing in our community, it's exponentially growing. Or within my lifetime, the way that memory has done in computers, where we've exponentially grown, the amount of memory that we have has exponentially grown over my lifetime. I mean, from none at all to a lot. Here, this we call exponential decay. When my base is larger than 1, I get growth. When my base is smaller than 1, I get decay. Yeah, your mom's memory is decaying exponentially now. Yeah, mine too. It's slowly decaying. Your mom's name is memory? Really? That's cool. So whenever I think exponential decay, I really go dark, and I think death. Because when we die, our bodies exponentially decay. At first, we decay really quickly. The skin and all the muscles and liquids and stuff in our body decay away really fast. But then, slowly, once we get down to like bones, we're done with the tissues and stuff, then the bones take a long time to decay. So at first we're decaying rapidly, and then once we get to a certain part, we decay slowly until eventually we never completely go away. Never completely are we gone. Turn to dust. But we're never gone. So when we die, we exponentially decay. So the difference between the virus growing and us dying, growth versus decay. Now, I want to graph this one. So I've got his parent. This is the parent of those. I know, Thomas, that's what I always seem to do. Then I want to graph him. So what do you think this plus 3 is going to do to my graph? What's going to happen to my graph with that plus 3? Can't seem to catch tonight. I've missed it like more times than I've caught it. What's that plus 3 going to do? The lag is real tonight. What's the plus 3 going to do? Notice it's up there with the x values. So it's affecting my x values. So thinking, good, guys, y'all did it. Good, that's exactly it. So horizontal, so it's going to affect those x's, and it does the opposite of what you think. So instead of adding it, we're going to subtract our 3 from each one. So I'm going to do a -3 to each of my x's. Or I could just shift it all over 3 spots. So I should have a point at -5, 4. Here, I'll do that in black. -5, 4. Negative 5, 4. 1, 2, 3, 4, 5, 4. At negative 4, 2. 1, 2, 3, 4, 2. At negative 3, 1. At negative 2, 1/2. And at negative 1, 1/4. Notice, though, that my asymptote stays right there. It doesn't shift it up or down. It just shifted it to the left. So still, as I get bigger and bigger, it's still going to get closer and closer to 0. As my x values get bigger and go towards infinity, my y values get closer and closer to 0. So this is that new one. Maybe I should have done it in red. So these guys, the transformations are the same as they were before. Yeah, only the x was moved. That's right, Austin. Only the x was affected there, not the y values. All right, let me do another. And then we'll look at the exponential function. We'll look at another irrational number that maybe you're not familiar with. So let's get where we are graphing. Let's graph. How about we do 3/4 to the x plus 2 minus 1, and let's stick a negative out front. Now remember, the negative out front, this base is still positive. Cheyenne's always trying to get me to do our homework for her, but I don't want to do your homework. Don't do that. No, 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 no. No, 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 no. I know better than that. That's for you to practice. You can do it. It was a nice try, though. A nice try. Nice try. Oh, and you're right. It's going to be a decay because it's going to get closer and closer. It's because it's in the homework. That's why he wants me to do that one. Smart, though. It was a nice try. Nice try. Do your own push-ups. That's why I keep telling myself, I have to do the push-ups. I can't just watch them do the push-ups. It's not working so far. Watching is so much more fun. Oh, you may change numbers. Okay, did I do that? Is this good enough? It's close enough anyway. Close enough. That's what I was doing. That's what I was doing. I was trying to think of you. This one's actually harder. It's a little bit harder. You can do it though. If we can do this one, we can do them all. Oops, I cheated and told you what we did first. So first thing we want to do is start with the parent. We got this big complicated thing, but all we're going to do first is start with the parent. So that's where we start. Start with the parent like this, 3/4 to the x. So see, it's just the base with the exponent. So I'm going to start there. I got you. I got you. If we can do this one, we can do any of them. Except we are going to look at this irrational number e here in a minute. But you can do it. We can do this one, we can do any of them. So what is this raised to the -2 power? See if you've got it now, if you can remember what that -2 means. So that negative, remember, is going to reciprocate it. It's going to flip it around. So it reciprocates it. and then we still have the 2. So the negative part does this. It reciprocates it. That's right, Rachel. The parent is always just your base with your exponent. That's it. You got it. So now, this is 4/3 times 4/3, which equals 16/9. Then, 3/4 to the -1 power, this reciprocates it, so it just becomes 4/3 to the first power, which is just 4/3. 3/4 to the 0 power, well, any non-zero number raised to the 0 power is just equal to 1. So that's just equal to 1. Then 3/4 raised to the first power is just 3/4. And 3/4 squared is 3/4 times 3/4, which is 9/16. Okay, I'm going to graph that parent first. Although if this is the question on the homework, you don't have to graph the parent first. You just need to find the points for the parent first. But I'm going to go ahead and graph this parent first, and then I'll graph this one in a minute. But tonight, if you're just doing this one, just use your points from your parent, and then just graph that. You don't have to graph both of them. All right, so I'm graphing the parent. -2. 16/9. Notice that 9 goes into 16 one time, but not 2. So almost 2. 1 and a little bit. -1. 4/3. Well, 3 goes in there one time with 1/3 left over. 0, 1. 1 3/4, 2 9/16, and just like September told me, it's decaying. Notice that this graph is decaying. That was smaller than 1, so it was supposed to decay, and sure enough it did. My asymptote is still at the same spot, so if I keep going smaller and smaller numbers out here. Actually, if I go smaller and smaller, I grow. And if I get bigger and bigger, because the bottom's going to be bigger than the top, it's going to get smaller and smaller and smaller, but never hit 0. So all those things that were true before with my parent are true again. Asymptote, y equals 0. Domain, all real numbers. Range from 0 to infinity. Y-intercepted, 0, 1. Good job, good job. Now let's graph this family member. This one's a lot more complicated. It's got lots of things going on. So notice it's got a negative out front. What's that negative out front going to do? Remember what a negative out front did with our functions when we had a negative out front? I'm just going to write down those points again right here, 16/9. -1 4/3, 0 1, 1 3/4, and 2 9/16. While you tell me, what is this negative out front going to do? Remember with our functions, if I had like a negative x squared, what did that negative do to it? Or if I had a, oh yeah, good, Cheyenne, it reflects it. Excellent. So this is going to reflect it. And because that's exactly right. What, -1 times your y. Good, Robin. Exactly. It's your y values that are reflected. Perfect. Then what about this +2? What's going to happen with that +2? What's that going to reflect? What's that going to do to it? What's that going to do to my graph? What's going to happen to my graph with that +2? Remember that +2 is up there with my x values. And my x values, you know, I think are on that horizontal line. So horizontally, so what's going to happen with that +2? Yeah, it's going to move it to the left 2 spots. Or I'm going to take all my x values and subtract 2, or add a -2, however you want to look at it. Perfect, guys. Then last but not least, this piece, what is it going to do? What is this -1 going to do? It's not up there with the x's. It's down here, down below. So therefore I know it's going to do it with my, oh, you're right, it goes to the right. Don't be fooled. Oh, no, that's right, to left, left. Okay, good. Yeah, you said left, Then, because it's down there with the y's, it's going to affect my y's, so this one's up and down. And you're right, it moves it down 1. And my y's are truthful, so it's just y -1. So I got a translation, a horizontal translation, and a vertical translation. Now, there are more than one things happening. Here I'm multiplying, and there I'm subtracting from y. You remember with those order of operations with the transformations? I've got to do my horizontal translations first. And then our dilations, we learned to spell that the other day, dilations and reflections. And then our vertical transformations or translations, vertical translations. Remember that order of operations? So we have to make sure we do the order of operations. Is it blurry over here, Cheyenne, or is it blurry everywhere? I can't seem to make the camera be all nice and clear. So I'm going to do each piece of it, but I have to make sure that I do them in the right order. So I'm going to do the horizontal translation first. So I'm going to shift it first here. I'm going to do a -2. I know the lag is real tonight. That rain will do that to us every time. So I'm going to take all my x values and subtract 2, or add a -2 to each one. So I have a -2 minus 2 gives me a -4. -2 minus 1 is a -3. That's a -2, a -1, and a 0. I'm kind of cutting in and out. A lag is happening. I think it might be on my end. I think it could be on my end. It might just be me. Over here. Yeah, I don't know why on the right and on the left it has a tendency, it has something to do with the way the camera's set up. It fuzzes out on the left and right. That just says horizontal translations, dilations, reflections, and then vertical translations. Those order of operations that we did before. Then here I have to do I don't have dilations, but I do have reflections. So in other words, I have to do this and then that. So it's a -1, we're multiplying, and then we're adding and subtracting. Remember with your y's, it's the opposite thing. Opposite of what you think. I mean, with your x's, it's the opposite of what you think. But with your y's, it's normal. You multiply and then you subtract. So we're going to multiply by -1. You can do it, Thomas, just a little longer. Just a little longer. We're not even going to go that much longer tonight. I just have to show you one more thing after this. You can make it, you can make it. And then we're going to subtract 1 from all those y values. So you multiply first and then subtract. Totally makes sense. When you're dealing with your x's, though, it doesn't make sense. Never. Never does it make sense. And here, Robin, I think it is smart just to go ahead and do fractions here. So to make this into ninths, I'm going to make that 9 ninths. So that I end up with -25 ninths. Here, this is thirds. So 3/3 is the same as 1, so I'm just going to subtract the 3/3. So then I'm looking at a -7/3. This one is a -2. Again, I have to have a common denominator, so I'm going to go ahead and turn that into fourths. So 1 is equal to 4/4. So I have a -7/4. And then last but not least, this one's 16ths. So I have a -27 16ths. All right, so what should happen is it should take this graph, move it to the left, flip it, and move it up, down 1. Those are the things that should happen. Let's see if it does. So -4, -25 ninths. Well, 9 goes in there almost 3 times, but not quite. So 2 and a little bit. So -4, -2, almost 3. This one, -3. 3 goes in there 2 and 1/3 times. So -3, -2 and a third. So -3, 2 and a third. -2, -2. That's a nice one. One nice, pretty one. -1. Well, 4 goes in there 1 time with 3/4, so 1 and 3/4. So -1, 1 and 3/4. And 0, and this is 1 and a little bit. That's not looking too exponential on there. But think about it, it's going to take it and reflect it. The last one is off. You think so? Let's see. Oh, you're right, because look, these two are positive. Thanks. That's why it didn't look right. I was like, it doesn't look right. It doesn't look like an exponential, does it? So I'm doing something wrong. And you're right, you caught it. This should be positive. So that should make it a -1/4. That explains it. -1/4. Even more like this. And then this one should make it a -7/16. And this one too. Why did I make them? Oh, because they were negative. Never mind. Man, I'm not quite there. I switched from negative on purpose because they went negative. So it's just this bottom one I can't add. I'm with you now. I'm totally with you now. I'm totally with you now. I got you. So we made them negative when we multiplied by the negative ones. And then we're just subtracting, but I can't subtract, obviously. Add, really. 9 plus 16 is 25, not whatever I have. I got it now. I'm with you now. I'm not with you. You're with me. Way to be. Just making sure you're with me. So that's 1 3/4. So that is 1 3/4. And this last one is at negative 1, not quite 2. 1 and some odd 16ths. And remember what's happened is it's flipped down like this. So it's coming like this. Now let's think about that asymptote. Yay, I got it. Let's think about that asymptote. Where's that asymptote going to go? Well, it was on the y value, so you know 0 times the negative 1 is still 0. But then it moves down. Yes, Fernando, for sure. I'll be adding that to her thing. When I'm adding comments, you got it. You too, Fernando, yeah. Yes, keep commenting. Okay, 0 minus 1. I pay attention to those comments. 0 minus 1 gives me a negative 1. So my asymptote ends up being here at y equals negative 1. So it turns out that whatever we're adding or subtracting on the end there is what our asymptote is going to be. So if I have something that I'm adding or subtracting to my exponential function, that's where my asymptote is going to end up. So that's a way to check your asymptote each time. You know, if it's not adding anything, it's adding 0, then your asymptote is where y equals 0. But if you're adding or subtracting something, then that's where your asymptote ends up. Okay, one last thing. I got it, one last thing. And that is, I'm going to show you this crazy number e. Big deal about this, though, is you start with the parent. Start with the parent, get yourself parent points. Then do your transformations just like you did in the past. So again, you know how we've been practicing things that we've learned before. We're getting to practice those transformations here. So if you didn't practice those before, you're getting to practice them now. Math just builds upon itself. And if you practiced before, it makes it a little easier to do it now. But if you didn't practice then it makes it harder now. All right, one last bit, and then I'm going to show you a little bit about what we're doing next week. But really, this is the last little bit. Y'all all know this number. Everybody's familiar with pi. You know, that one everybody knows. It has to do with circles. Everybody knows about pi. And I can't remember if we've looked at e or not in this class, but e is just another irrational number. Euler's number, or e. Yes, Fernando, that's exactly right. 2.718281828 45 90 45 forever and ever and ever. It just keeps going on, never stops. You got it. What we need to know is it's almost 3. It's 2.7. Almost 3. So you need to know that e is approximately 2.7. So this is the approximation. But this is the exact number. And E comes up when we talk about finances, especially when we compound our interest continuously. That's where E was first found. You're going to need to know that E is 2.7-ish, and you also need to know that E squared is approximately 7.2. So a little bit more than 7. 7.29, I think. So almost 7.3. Somewhere right in there. A little bit more than 7. And this E is known for when we're doing things with exponentials, like when we are compounding our interest continuously, we have this exponential growth that's happening. And so I'm going to take that, and we're going to learn about like the exponential function is f of x is equal to e to the x. I don't think I understand the question. Clarify intercepts are where the graph crosses the x or even y-axis. Yeah, wherever it crosses the y-axis, we call it a y-intercept. And wherever it crosses the x-axis is the x-intercept. Yes. Yeah. So anywhere on here is a y-intercept, and anywhere on there is called the x-intercept. You're right. You had that. You said it. You did it exactly. Okay, so back to graphing this thing. When I get ready to graph him, I'm going to use these numbers here to help me out. I know I can put in any old x value. So x can be -2, -1, 0, 1, and 2. And then we're just going to plug those in, or substitute that in for x. So you got e to the -2. That negative reciprocates it. So you got 1 over e squared. And e to the -1, that reciprocates it, so you just have 1 over e. Then, if we look at it, it's like 1/7-ish. And this is 1/3-ish. 1 over 2.7 is about 1/3. When we get ready to graph, that's the value we really need to know. And then e to the 0, well, anything raised to the 0 power is just equal to 1. And then e to the first power is just e, and e squared, we said earlier, was about 7.29. When you label your points with e, you're going to use 2 comma e squared. You're going to label it in exact form, 1 comma e. But we need to know that that e is almost 3. So it's going to look like this when I graph it. -2 and about 1/7-ish. -1 and 1/3-ish. 0, 1. 1, 2 and a little bit. Almost 3. And 2, 7 and a little bit. 3, 4, 5, 6, 7 and a little bit. Oh, right there. Notice that that is exponentially growing. And there's nothing being added or subtracted out here, so my asymptote is where y equals 0. So don't freak out just because you're using that e. It's just a number. And this is the, no, it's a different E. So this is an element. And it literally is just notation that just means an element. That's right, Fernando, it's different. It's just an element, and then this one is actually the number. This is a number. It's 2.71-ish. So those are two different things. And I kind of write them different. This is a symbol for an element, and this is an actual number. So when I get ready to label these points, I'm going to label them 1e, 2e squared, negative 1, 1 over e squared, no e, and negative 2, 1 over e squared. So notice I'm labeling them with that exact form. But to graph them, I needed to know about where they were. So there's the exponential function. Now I can do something like add 1 to it, in which case I just add 1 to all those. I shift them up all one spot. Or I could do x minus 1 where I add 1 to all my y values. I mean my x values. So the same thing's true with here. You can do things with that, transform it, just like you did before. Start with this parent in order to do those transformations. Now tonight, this is your job. You're just going to be graphing these exponential functions. And I think there are like 12 of them, like Cheyenne said earlier. I think there are about 12 of them that you're graphing. Next week, we're going to find the inverse of these. And everything we're going to be doing is the inverse of an exponential function. So, and we call those logarithms. So next week we're going to look at the inverse. So if I have something like this, you know the 4 steps of to finding an inverse. The first thing is you swap that out. Then you swap out your x's and your y's. And then you solve for y. Well, getting that y out of that exponent, be thinking about how we can get that y out of that exponent. And as you watch your video that you're watching for your application task this week, you can learn a little bit about logarithms. See how logarithms work. All right. I know this is off topic, but I feel like it's going to be a very critical that I know for homeworks and the quizzes. Oh, to clarify that is equals a -4. It's not going to equal a -4. I don't quite understand. 2 to the second is -2 times -2, and that equals -4, huh? Maybe Amanda answered it. Good job, Amanda. Thanks for handling that. All right, guys, go do those exponential functions tonight. Next time, we're going to learn about logarithmic functions. We're going to learn what a log is and be able to solve some logarithmic functions. And hopefully it won't be so laggy next time. All right, see you on Discord. Y'all can come join me, tired or not. You can come get your math done, get it out of the way. If something happens, you can't join me tonight, I'll be on and off tomorrow, mainly on tomorrow, so if you need me, I'll be on and off tomorrow, so you can find me there. Hey, math made simple, let's have some math. Thanks for watching. See you on Discord. Oh, it's the -2. What is in the negative?